Hi, I'm Papia. Today we will learn how to evaluate a definite integral. Now, this is the definite integral given to us, integral from -2 to 1, and the function is absolute value of 4x. Now, you know the method. We have to find the antiderivative, then we have to apply the fundamental theorem of calculus by plugging in the values, and we will solve the integral, right? But know that not every function you can find the antiderivative easily. So look at this function. It's the absolute value function. Do you know any function whose derivative is this one? Not directly, right? So for those type of functions, we have to first understand the function a little bit, maybe understand what kind of region we're talking about, and then try to evaluate it. So let us look at the function absolute value of 4x. Now, you know that absolute value function, the graph is like a V shape, right? But this is not absolute x, this is absolute 4 times x. So let's understand what the function will look like. So we can think of it as, we can split the absolute value into absolute value of 4, absolute value of x. And you know what absolute value does. Every time you plug in a negative number, you get a positive. And if you plug in positive, you get positive. Now, since 4 is already positive, you don't need the absolute value. It's just 4. But x can be positive or negative. So you keep the absolute value there. So basically, this function is 4 times absolute value x function. So the v, but is 4 times. So what does that mean? Let's split this function into 2 parts because it's made of 2 different lines, and let's understand it. Now, remember, what is absolute x? It is positive x when x is positive. But this is 4 times, right? So it will be 4 times x when x is positive. What happens if x is negative? Well, then if you plug in a negative value, you still get a positive, right? How do you get that positive? By having a negative of x. So the absolute 4x is actually made of these 2 lines. When x is positive, you get 4x. X is negative, you get negative 4x. So let's graph it and see if we understand. Well, for positive x, it will be the line 4 times x. So let's see if this is, say, x equals 1. So at 0, it will be 0. And at x equals 1, the y value will be 4. So let's say this is 2, 4, 8, 6, 8, so on. So at 1, the value is 4. So this positive side, it will look like this line. For the negative, so at -1, the value will still be 4. At -2, the value will be 8. So let's see. So this is the v that you will get. Okay, now notice which area we have to compute from -2 to 1. So basically from -2 to 1, right? So the area will be between -2 and 1. So this area of a triangle and this other area. So that total area will give you the definite integral. Okay, so how do we compute this total area? Now notice you cannot just integrate from -2 to 1 directly. What we want to do is break it apart into 2 different integrals, which will give us 2 different areas. And that's a property of definite integral as well. So we can say that this definite integral is actually going to be one from -2 to 0 and the other one from 0 to 1. Now notice from -2 to 0, what does this line look like? Well, this is for x less than 0, so it looks like -4x. And from 0 to 1 is when x is positive, so the line is just 4x, positive. So notice, now we don't have absolute value, and we can just apply a power rule to figure out the antiderivative. All right, so let's complete this problem. Let's find the antiderivative. First of all, you can take out the -4, is just a constant, take it outside, and then x has a power 1, so its antiderivative is x to the power 2 over 2, and then we'll plug in -2, 0. For the second integral, you take out 4, and then x again has a power 1, so same antiderivative, x squared over 2, plug in 0 and 1. And now we are going to, we will apply fundamental theorem, but if you want, you can simplify a little bit. See this -4 over 2, this is just -2x squared, and this one will be 2x squared. All right, now apply fundamental theorem. Okay, so for this one, plug in 0 first, you get 0. Then subtract, don't forget, you have to plug in -2. So here, be extremely careful because you have a -2 and you're plugging in -2 for x and square that. So that's the first, from the first integral. Now from the second one, you're plugging in 1 for x, so 2 times 1 squared, minus, when you're plugging in 0, you just get 0. All right, so let's simplify. Okay, notice this is just +4 times 2, that's 8 with a negative, so -8 with a negative on outside, so this is just +8. And here, 1 squared is 1, 1 times 2 is just 2, so you add 2. So total is 10. So 10 square unit is the area of this region under the curve absolute value of 4x. That completes the problem. Thank you.